So we continue with chapter 4, and which is the consumer choice. So last time we start with the preferences, and we basically explain it is a way to explain the taste of individuals. Okay, so screen, just a second. Now you can see it, I guess. Okay, perfect. So sorry for that. So last time we start with the consumer choice, and we introduce what the preference means. And the preference is basically the way to explain the taste of individuals over bundles of goods. Okay, so basically bundles of the goods is the quantities. Okay, so let's say that so we are in an economy which is composed of only two goods. Okay, so let's say that the first good is coffee and the second good is tea. Okay, and let's say that so we are considering x. Okay, x is composed of, let's say this is x1. x1 is composed of c1 and t1. Okay, so this is bundle, and c1 is the amount of coffee. Okay, and t1 is the amount of tea. Here the amount will be cups. Okay, so the cups of tea and cups of coffee. Okay, so this is basically an option. Okay, so for your consumption. Okay, so you can just think that this is an option for your consumption. Okay, this is just one bundle. Okay, so there can be many other bundles here. Okay, so let's say that so we are considering an alternative bundle, so which is composed of C2, T2. Again, C2 and T2 are the amounts. Okay, so this is the cups of coffee. Okay, some cups of coffee, and this is the cups of tea. Okay, and we are interested in how you rank. Okay, how do you rank x1 and x2? Okay, so I'm giving you two different options here. So x1 and x2 are given to you. Okay, so what do I mean by given? Okay, so basically you have these two choices. Then I basically ask you, so which bundle do you want? Okay, remember here, whenever I say bundle, okay, if you would like to give an example here, this can be 2 cups of coffee and 1 cup of tea. This can be 2 cups of coffee and let's say 3 cups of tea. Okay, so we are basically looking for different amounts, different cups of coffee and different cups of tea, and I am asking, so which one would you prefer? Okay, so basically what I'm asking you, what is your preference? Okay, as you can see here, okay, for example, in the real life, okay, so if one cup of coffee is, I don't know, 10 Turkish liras, okay, at Starbucks, and one fincan, one cup of tea is just 2 Turkish liras in the küçük ev, okay, so you can have different thoughts in your mind, okay, so you can just think about whether you can afford it or not, okay, but here no price, okay, so we haven't talked about price, okay, and we haven't talked about the income, okay. Don't think about their prices and your income, okay. So we are just interested in your taste, okay. So let's make the question more concrete, okay. So if I ask you, so which one, so, okay, so if you will have just one thing to do in a day, okay, so you will either consume 2 cups of coffee and 1 cup of tea, or 2 cups of coffee and, okay, so this is a silly question, okay, so let's make it more realistic. So this is 2 and 4, this is 3 and 3, okay. So which bundle would you prefer? Okay, so X1 or X2? Just write it down. Just two people are responding. Perfect. Okay. So as you can see, you have different answers here. Okay, and so which means that you have different taste. Okay, and we are basically representing your taste with using the preferences. Okay. So we say that, for example, if you prefer X1 to X2, then we write X1 is preferred to X2. So if you prefer X2 to X1, then we write X2 is preferred to X1. And if you are indifferent between X1 and X2, then we write X1 is indifferent to X2. Okay, so this is the notational representation. Okay, so last time we said that, so the preferences we will have 2 assumptions on the preferences, 3 assumptions on preferences, and the first one is basically saying that completeness, and this is you can rank any 2 bundles. Okay, so by ranking, okay, so you don't need to understand that one of them should be preferred to the other one. Okay, so you can be indifferent here. Okay, the only thing that we are asking is you need to answer in a way that, okay, so you either prefer the first bundle, the second bundle, or you are just indifferent between those 2 bundles. Okay, so you shouldn't answer that, so I cannot rank them. Okay, the second one is the transitivity, and basically, so this is saying that preferences are consistent. Okay, so what we mean by the consistency here, suppose that we have another bundle, okay, x1, x2, and x3. Okay, so all of them are representing some amount of coffee and tea, and you know that you prefer x1 to x2, and you also prefer x2 to x3. If I don't say anything about the relation between x1 and x3, okay, that the consistency requires. So what would be the consistent preference relation here? Do you expect x1 is preferred to x3 or x3 is preferred to x1? Okay, so yes, x1 is preferred to x3 will be the consistent one. Okay, so basically the transitivity is saying that, so if you have this two relation between two goods, okay, three goods, then the relation between x1 and x3 should be in a consistent way. Okay, so the third assumption is more is better. Okay, so it simply says that, okay, so it is self-explaining itself. Okay, you would like to consume more. Okay, so of course this does not hold for bad goods. Okay, for example, pollution, traffic, etc. Okay, so let's make it more concrete here. So if x1 is 2 and 1, whatever the goods are, and x2 is 2 and 3, and x3 is 3 and 3, basically your preferences will be as follows. Okay, so since more is better, so under x3, so you consume more of both goods, okay, compared to the other bundles here, than x2, than x1. Okay. Is everything clear right now? Is everything clear? Sorusu olan var mı? So right now, so we just went over what we have done on Friday. Okay. So let me draw a simple graph here, okay, to give you the idea, okay, what we mean by the bundles. So let's say this is coffee, okay, and this is tea. Okay. So we are basically representing the bundles here. This is 1, 2, 3, 4, 5. This is 1, 2, 3, 4, and okay. So for example, one bundle can be this one. Okay, so let's say this is x1 bundle. This is x2 bundle. Let's say this is x3 bundle. Okay, so the numbers are clear here. Okay, so for example, for x2 you are consuming 3 and 3. For x3 you are consuming 4 and 2. For x1 you are consuming 2 and 2. Okay, so all those three assumptions, okay, can help us to understand the relation between those three groups, three options. Okay, so okay, do those three assumptions tell anything about the relation between x3 and x1 by just using those three assumptions? Okay, can we say so which one is better, which one is preferred? X1 will be less preferred. Okay, so which means that x3 is preferred. Okay, does that, well, how about x2 and x3? Okay, so do those three assumptions say anything about x3 and x2 and x3? So this follows from more is better, but here, just by using those three assumptions, okay, we cannot say anything about x3, x2, and x3. Okay, to answer that, we need to know actual references. Okay, and one thing that we will be using to represent these actual preferences is called indifference curves. Okay, so before going to more detail, okay, so let me ask you a very simple question. Okay, so if I say something like this, okay, so let's say this is another bundle. Okay, so as you can see, this is 3.5, x4 is 3.5 and 4. Okay, is there a problem there? Can we have such a bundle? Why cannot we have such a bundle? Excellent. Okay, so which is okay, so logically right. Okay, so you are right that so we cannot have 3.5 cups of coffee. Okay, you cannot say that you cannot go to Starbucks and give your cup and so you can just say that okay, half of it, you cannot say that. But so in economics, okay, so we will be basically thinking that such bundles are possible. Okay, so no matter it is fraction or not, we don't require it to be natural numbers. Okay, we don't require it to be, yani let me explain in Turkish. Burada tam sayı olmasına gerek yok. Hani burada 3.5, 4, 3.1, 4.7 bundle'larımızda bizim geçerli. Okay, so we are not requiring a bundle to be composed of integers. Okay, we can have fractions in bundles. So is this clear? Okay, because so if you think this does not make sense, okay, then you will definitely have some problems in the midterm or the final. Burayı sadece matematik olarak düşüneceğiz. Tamam mı? Hani burada 3.5-4 bundle gibi bir şey olamaz. 3.5 kahve alamazsınız. 4.7 kahve alamazsınız. Fakat biz buradaki we will think that so all the points on this dimension is possible. Do you have any question? Okay, then let me ask you one more thing again. Okay, so let's say that one more bundle. Okay, so let's say that this is bundle X5 and it is 2.3 and 4.2. Does such a bundle is such a bundle possible? The correct answer is yes. Okay, so all buradaki bütün noktalar, hani olabilecek bütün kombinasyonlar, all combinations that you can think of, they can represent a bundle. Okay, as long as, so basically, so we are on this quartet. Okay, so bu positive and non-negative. So as long as, so we are having non-negative amount. Okay, so everything is possible. Okay, then we will have here infinitely many bundles. Okay, we have infinitely many bundles. Then we will make the bundles that we will make a set with the bundles that we are indifferent with. So we will combine all the bundles. Okay, so that gives us to the same satisfaction. Okay, we will take all bundles giving us the same satisfaction. Okay, and we will represent them as a set. Okay, so formally we will say an indifference curve is the set of all bundles of goods that a consumer views as being equally desirable. This is just the set. Okay, so basically, so we just would like to say that. Okay, so let me try to show it on the graph. Okay. So let's say that this is our graph. So we have coffee here, we have tea here. Let's say that, so we are considering 2 cups of coffee and 1 cup of tea. Okay, so we are starting with this blue point. Okay, then I'm asking myself, okay, what if I give up some amount of tea, okay, just a little bit amount of tea, okay, and instead I am getting more coffee. Okay, so which means that I am moving from blue dot to the red dot. Okay, and I say that I'm getting the same satisfaction here. Okay, so both those dots are, both those bundles are the same form. Okay, so which means that these two are on the same indifference curve. Okay, if I do more, okay, for example, if I say that if I increase the amount of tea, okay, with sacrificing some amount of coffee, okay, so let's say that that is dot green, okay, Can you see those dots? Okay, can you see my drawing? Perfect. Okay, then I am still indifferent between this blue dot and green dot. Okay, so green and blue I am indifferent with. Okay, I am indifferent with blue, and so let me make it more clear. Okay, I'm taking just those 3 points. Okay, so I'm indifferent between green and blue. Okay, so I'm indifferent between blue and red. By using transitivity, I'm also indifferent between green and red. Okay, I can continue like this. Okay, so I can draw the yellow one. I'm also indifferent between green and yellow. Okay, and I can also relate those relations here. Okay, so basically, if I continue like that, so let me use okay, I can combine all those dots. Okay, that I am indifferent with. Okay, so this will gives us the set of bundles that I am indifferent with blue dots, blue bond. Okay, so which means that so no matter what you consider a, a bundle on this curve, okay, this purple, so you are indifferent between purple and the yellow one, the purple and the green one, the purple and the blue one. So we can draw other indifference curves here. Okay, so this is another indifference curve. Okay, so this is another indifference curve. Okay, so it is just the set of the points that you are indifferent with. Okay, then let me ask you one question. So let's consider, let me find a different color here. Okay, so the orange one. Okay, so let's say that this is the orange one, orange bundle, and I'm comparing it with this black bundle. So can you think that so you are indifferent with, can you be indifferent between orange and the black bundles? Okay, so there are some answers yes and no. The the correct answer will be no. And the reason is basically so if you were indifferent, they should be on the same indifference curve. Okay. If you were indifferent, they should be on the same indifference curve. However, since they are on the different indifference curve, since they are on the different indifference curves, you either prefer orange over black or black over orange. Okay. So then let me ask you another question here. Okay. Which one is preferred? Okay. Orange or black? Okay, by using those indifference curves. Okay. Okay, so there are two answers, orange or we cannot decide. Okay. So if I didn't have the indifference curves, okay, if we are not informed about indifference curves, okay, so let's say that, so if I don't know the exact indifference curve that they are on, okay, then what I am doing is I am comparing this black one with this orange one. Okay, here I cannot know. Okay, if there were no indifference curves here. Okay, the reason why I cannot know is basically, so if you remember, so the previous examples that we were talking, okay, we were using the more is better rule. Okay, we cannot use more is better rule here. Okay, but we have indifference curves. Okay, for example, can I use the more is better rule? Okay, by if I want to compare this orange one and this gray one. Okay, can I use more is better rule to compare orange and gray? What's your answer for that? So let me explain in Turkish. Okay, so burada turuncu ile griyi karşılaştırmak istesek more is better kuralını kullanabilir miyiz? Ya da turuncuyla griyi direkt karşılaştırabilir miyiz? So basically, so I'm not asking, so you are right, okay, so they are not on the same indifference curve, okay? But forget about the indifference curve, okay? Let's say that, so gray is here, okay? Forget about the indifference curve, okay? Just by looking the exact amounts of the orange and the gray one, okay? Can I compare them? The answer will be yes. Okay, so as you can see here, if you go from this direction, okay, orange has more coffee than gray has, and has more tea than gray has. Okay, so we have both more of coffee and more of tea. Okay, so when we compare orange and gray, okay, and which means that orange is better than gray. Okay. Then can I compare gray and black? Can I say anything about them? So by the way, so you write gray with E. Okay. Can I compare gray and black? Now I'm considering the indifference curves. So once I know they are on the same indifference curve, what I can say, so if they are in the same indifference curve, they are giving me the same satisfaction, right? So which means that since they are on the same indifference curve, I am indifferent between them. Okay. Then if I turn back to here, I prefer orange to gray. Okay, so this follows from more is better. This follows from same indifference curve. Okay. Then what can I say about orange and black? So which one is preferred? Turuncu mu, siyah mı? Orange is preferred, and this follows from CV. Any question? Sorusu olan var mı? Good. So let's continue then. Okay. So I try to illustrate and properties of the indifference curve through this example. Okay. So let's list them formally. Okay. So indifference curves have five important properties. Okay. The first one is bundles on indifference curves farther from the origin are referred to those on indifference curves closer to the origin. Okay, so what do I mean here? If we consider this graph, okay, so this is the origin. If I consider this blue one and this orange one, okay, since orange is farther, it is preferred to what it is. The bundles on orange are preferred to bundles on blue. Okay. So any bundle that I consider on orange is preferred to the any bundle that I consider on the blue one. Okay, and this directly follows from the more is better assumption. Okay, so this is the first property. The second one is there is an indifference curve passing through every possible bond. Okay, and this follows from the completeness assumption. Okay, so which requires that you should be able to rank all the bundles. Okay, the third one is indifference curves cannot cross. Okay, what does it mean? So let's think about this graph. Let's say that this is indifference curve 1 and this is another indifference curve. Okay, so they are crossing each other, right? So on this, they are crossing each other on this red, at this red point. Okay, and basically, so this property 3 is not permitting such instances. Okay, can we explain why such instance cannot happen here? Why we cannot have two indifference curve crossing each other? Burada sözü olarak anlatabilirsiniz. Sonra Türkçe de olabilir anlatmanız. Neden burada iki tane indifference curve birbiriyle çakışmaz? Why two indifference curve cannot cross? That's good. Okay, so they have different values. They are giving different satisfaction. But for some point they are giving the same satisfaction. Then what will be our explanation? Hadi söz alıp açıklayın bunu biriniz. That's right. Okay. Let's okay. So let me try to be more detailed here. So in the explanation, okay. So let's say that this red one, okay. So since they are on the same indifference curve, okay. So this red one, okay. So blue is indifferent with red one, right? Is that clear? They are in the same indifference curve. Açık mı burada mavi ile kırmızının aynı satisfaction'ı verdiği bize? Good. So what about let's consider this green point, okay? Green and red is also giving us the same satisfaction, right? So because they are in the same indifference curve. Okay. So green is also giving the same satisfaction with red one. Then what about blue and green one. So the transitivity explains that with transitivity, they should be indifferent. Is that clear? So if blue is indifferent with red one, and if red one is indifferent with the green one, then by using transitivity, we can say that blue is indifferent with the green one. Any problem there? Is there any problem there? There is no problem there yet. But at the same time, more is better is telling that blue is better than the green one. Okay, and this follows from more is better. Exactly. Okay, so which means that, so these two, okay, so we have green is indifferent with the blue one, and blue one is better than green one at the same time. Okay, cannot happen at the same time. So this is a contradiction. Okay. Sorunuz var mı burada? Okay, perfect. Then let's continue. The fourth property is basically saying that indifference curves slope downward. In other words, so we say that they cannot slope upward. Okay, so what does this property is telling us? Okay, so if you consider the graph here, so suppose that we have an indifference curve, okay, which is sloping upward. Okay, then let's consider two points here, this green one and this blue one. Okay, so since green and blue are on the same indifference curve, green is indifferent with blue one, but due to more is better, blue is preferred to green one. Okay, so which means that, so we have these two relations at the same time. Okay, blue is preferred to green one, and green one is indifferent with blue one. So these two cannot happen at the same time. Burası açık mı? Is this clear? So which means that the indifference curves will be like this. Okay, so like this. Okay, so they cannot be upward slope. Okay, so for example, it can be like this. Okay, so but they cannot be upper slope. The fifth one and the last one is indifference curves cannot be thick. Okay, what do we mean by being thick? Okay, so let's say that we are working on the graph again. Okay. So this is our indifference curve. Okay, suppose that at this point, okay, so our indifference curve is this thick. Okay, it is thicker. Something like that. Okay, so why we don't allow such indifference curves? Okay, so why we cannot have such indifference curves? So let's say that this is a point on the indifference curve. Okay, so let's say that this is x1, and this is another point on the indifference curve, x2. Exactly. Okay. So as you can see here, okay, so when I magnify this indifference curve, so since they are on the same indifference curve, so x2 is indifferent with x1. Since they are on the same indifference curve, but x2 is better than x1 due to more is better, and so which tells us that x2 is better than x1 and x1 is indifferent with x2. These two cannot happen at the same time. Any questions? Sorunuz var mı? So this is basically so all about the indifference curves. Okay. So indifference curves is the graphical representation of the individual tastes. Okay. So basically we are grouping all the bundles which are giving the same satisfaction to us, and we are trying to relate the relation between the different bundles on the different indifference curves. Okay. So if we have the opportunity to work on always on the graphs, okay, we can do everything with the indifference curves, okay, but we cannot always use the graphs, okay, and whenever we cannot use the graphs, okay, so we need some kind of a mathematical representation of your, okay, when you cannot use graphs to represent taste, okay, we need mathematical representation. Okay, and we do it by a function called utility functions. Okay, So this will be basically, so if you remember the first chapter that we covered, we start representing the demand and supply with the graphs. Okay. Then we say that, okay, so we can also represent the demand and the supply by using a mathematical representation, which is the demand function and the supply function. In a similar manner, so whenever we cannot represent the taste, the satisfaction by just using the graphs, we need to have some mathematical representation, which we will call utility function. Okay. So utility is a set of numerical values that reflect the relative rankings of various bundles of codes. Okay, so here utility is just a unit. Okay, so it is something abstract. Okay, so you cannot say that, okay, so this is the 5 utility, this is 6 utility. Okay, so the important thing here is the relativity between those values. Okay, so it doesn't, for example, let me be more clear here. So it doesn't mean that, okay, so whenever I say that, okay, so you are getting 5 utility from this bundle, okay, and 6 utility over this bundle, we don't care about the exact difference between 5 and 6. Okay, so what we only care about is 6 is greater than 5, so that the second bundle is more preferred to the first bundle. Okay, so we are only interested in the relativity. Okay, we are not interested in the magnitudes of the utility that you are getting. Okay, because this utility is something that I'm making up. Okay, there is nothing called utility. Okay, utility function is the relationship between utility values and every possible bundle of codes. Okay, so we will represent utility function with u. Okay, and when I say that C1 and T1, okay, so this tells us how much utils. Okay, so this is the unit of the utility. Okay, we get when we consume C1 cups of coffee and T1 cups of tea. Okay, so if you compare C1 and T1, okay, so this is one bundle, and if you compare C2, T2, and suppose that the first bundle is preferred to the other one, what we need to require from our utility function is our utility function needs to give us a higher value. Okay, so when we consider the first bundle to the second one. Okay, so this is greater sign. Okay, this is preferred sign. Any question? So this is a little bit abstract. Okay, so I'm just using some functions to represent my taste. Okay, if a function is able to represent my taste, then whenever I compare two bundles here, if I prefer the first one, then whatever the function that I am considering needs to give me a higher utility. Okay. So let's say that our utility function is c1 to the power 0.5 times t1 to the 0.5. Okay. So this is our utility function. Okay. So I define our utility function as follows. Okay. So whatever amount of coffee, cups of coffee and cups of tea that you give me, I can calculate my utilities by using this multiplication. Okay. So let's say that we are comparing two bundles here. The first one is 16 and 9, and the second one is 25 and 4. Okay. So which bundle is more preferred? So which bundle is more preferred? Okay, so let's try to do it all together. Okay. Okay, why the first one and why the second one? Okay. So what I just need to do is basically I need to evaluate, okay, find the value of the utility that I am getting from the first bundle and the value that I am getting from the second bundle. Okay. Then I will just compare those values. Okay, so and which one is better, which one is greater, that bundle is better. Then here 16 to the 0.5, 9 to the 0.5, which will be 4 times 3, which is 12. The second one is 25 to the 0.5, 4 to the 0.5, which one is greater, 5 times 2, which is 10. Okay. Since 12 is greater than 10, then I can say that since the utility that I am getting from the first bundle is greater than the utility that I am getting from the second bundle, the first bundle is preferred to the second. Is that clear? Açık mı? Yani burada çok zor bir şey yok zaten. Sadece değerleri karşılaştırıyoruz. Hani fonksiyonda değerleri koyuyoruz. Hangi bundle daha yüksek utility veriyorsa o bundle daha iyidir diyoruz. Okay? So this is not that complicated. So what we are doing is just putting the corresponding bundles. Okay, so evaluating the corresponding bundles by using the utility functions. Then we are just comparing the values of those utility functions at those bundles, and which bundle is greater, the better the bundle it is. Okay. So let me do one more small thing, then I will give a break, and then we will meet after that. So So remember that an indifference curve consists of all those bundles that corresponds to that's giving to the same satisfaction. Okay, but now since we have one more tool here, okay, the utilities, then we can write that as corresponds to a particular level of utility. Okay, if the utility function is given as like that, then an indifference curve is given by some level of the utilities. Okay, so I'm representing it with u bar. Okay, giving us the same utility level. Okay, so this is some number. Okay, for example, if we give that number as 60, okay, so which means that I'm now looking for the bundles, okay, all the bundles giving me a utility of 60. Okay, and suppose the utility function is given as q1 times q2. Okay, can you give me some examples? Okay, can you give me some points which are giving me a utility of 16? 8 and 2 is 1, 4 and 4 is another one, of course, 16 and 1, and you can just think about the opposite of them, okay, just the reciprocal of them, okay, so which means that, so it can be 4 and 4, it can be 8 and 2, 2 and 8, 1 and 16, 16 and 1. Okay, so we can have many other points on the same indifference curve. Okay, so they are all on the indifference curve given utility of 60. Okay, any question? No question. Okay, then we will meet at 7 p.m. Okay, so let's give a short break. Okay, so we will meet at 7 p.m. Okay, I'm talking to report right now. We'll continue with the second part of the class. Let me share the screen again. Okay, perfect. So in the first class, so we start with the utility functions. Okay, so we said that utility functions are just the functions, okay, to represent the preferences. Okay. So, but there is something that we are more interested in, and it's called the marginal rate of substitution. And so what we mean by is, so we are interested in the value of coffee in terms of tea when you have a certain amount of both goods. Okay, so basically, so here again, okay, don't forget that, so we don't have any prices. Okay, we don't have any income. Okay, so we are just try to understand, so what is the equivalent, so if you are getting 5 utility from one extra coffee, okay, how much, how many cups of tea that you need to get the exact utility. Okay, so we are just looking for the relative utilities that you are getting from coffee and tea from. Okay, so marginal rate of substitution is the amount of one good that a consumer will sacrifice trade to obtain one more unit of another good. Okay, so for example, suppose that currently you have bundle 3 and 4. Okay, so you are currently consuming 3 cups of coffee and 4 cups of tea. Okay, and your utility function is C times T. Okay, so which means that with this current bundle, okay, your utility is 12. Okay, so this definition is telling us is the amount of one good that consumers will sacrifice, okay, to obtain one more unit of another good. Okay, then let's be more clear here. How many cups of coffee you would trade or give up to get one extra cup of tea? Okay, what's your answer here? Okay, so how do we find it? Okay, so again, okay, so what does it say that? Okay, so we are looking for x, okay, and we are increasing the amount of the tea that we would like to consume by 1. Okay, so we would like to get 5 more, so 5 cups of tea. Okay, and since this is a give up, okay, so basically you would like to achieve the same level of utility. Okay, so if you are achieving a lower utility, okay, then you don't want to give up. Okay, so this will give us a utility of 12. Okay, so which is equal to the utility of 3 and 4. Okay, then x times 5 is equal to 12. Then x is equal to 2.5. Okay, initially I had 3, now I have 4, 2.4, then I am giving up 0.6 cups of tea. Okay, so this is the sacrifice. Okay, so you are sacrificing one good, okay, to be achieving the same level of the initial bundle, and you will have an extra unit of the other good. Okay, how willing a consumer is to trade one good for another one depends on the slope of indifference curve at the consumer's initial bundle of goods. So let's try to visualize it. Suppose that this is the indifference curve that we are initially on, okay? And we are basically at this point. Okay? Then suppose that we would like to, okay, increase the amount of coffee that we are consuming right now. Okay, so let's say this is, I'm just giving number here. Okay, so this is 4, and we are interested in increasing the amount of the coffee that we are consuming 5. Okay, so this will corresponding to giving some level of some amount of tea that we will give up. Okay, so this is, so this distance is 1. Okay, and we are basically giving up some amount of tea here. Okay, and this is how much we would like to, how much tea we would like to give up. Okay, or you can just think about the opposite here. Okay, at this point, okay, so you would like to increase the amount of tea that you are consuming from 3 to 4. You still want to be on the same indifference curve. Okay, so this is 1, and this part is how much coffee we would like to give up. Okay. And so what we mean by the slope of the indifference curve at this point is basically the slope of the linear line, okay, passing through that point, okay, tangent to that point. Slope of tangent line is equal to the slope of indifference curve at that point. So let me explain this more. MRS depends on how much extra utility a consumer gets from from a little more of each good. Okay, so basically it is related with the extra utility, okay, which we will call the marginal utility that we are getting from each good, okay, consumption of each good. Okay, so marginal utility, to be more clear, utility is the extra utility that a consumer gets from consuming the last unit of a good, holding consumption of the other goods constant. So let me repeat it again. Okay, so MRS of X for Y. Okay, so if X is coffee, if Y is tea, is the maximum amount of Y for which a consumer is willing to exchange X. Okay, so let's try to see what we mean here. Okay, so we have marginal utility of coffee. okay? And we also have, so let's don't use a quote here. We also have marginal utility of t. Okay, so this is basically you can just think that the extra utility that you are getting from a very small amount of coffee and from a small amount of tea. Okay, for the margin rate of substitution, so we would like to be on the same indifference curve. Okay, so which means that, so whenever I'm increasing my consumption of good X, okay, good coffee by 1, okay, increase in the amount of consumption for coffee, I'm asking, okay, so what will be the decrease, okay, in the consumption of tea, okay? And the crucial point here is the extra utility that I am getting from this increase, okay, so this is the extra utility I get, okay, should be equal to utility I lose, okay? Since I stay on the same indifference curve, since I stay on the same indifference curve, the amount of utility that I am getting, okay, should be equal to the amount of utility that I am losing. Then, remember, we are calling this amount of y as MRS, okay? Then if I do the math here, okay, MRS, which is y, is equal to the marginal utility of coffee divided by marginal utility of tea. Okay. Okay. In fact, so it will be, so since this is some kind of a negative number, right? Okay. So we will explain in a few seconds, but this is the point. Okay. Şimdi burası önemli. And let me explain in Turkish first. Okay. So I will explain again in English. Şimdi burada bizim bilmemiz gereken konseptler, bir marginal utility konseptimiz var. Bu marginal utility de çok basit bir konsept. Bir sonraki extra unit of good consumption'ımızdan ne kadar utility bize gelecek. Tamam mı? Buradaki diğer ürün consumption'ımızı da sabit tuttuğumuz durumda. Ben marginal rate of substitution of coffee for tea'yi şu şekilde açıklayabilirim. Is the maximum amount of tea that you would like to give up, okay, to get one extra cup of coffee. Okay, so since I would like to be getting to be on the same indifference curve, okay, which means that I would like to get to the same utility. I don't want to lose anything. Okay, so that is the maximum amount. Okay, so you would like to get an extra cup of coffee, okay, without giving up anything. But here the question is, what is the maximum amount of tea that you would like to give up? Okay, then the maximum amount of the tea is basically, so you would like to give up as long as, okay, you are not worse off. So which means that as long as you still stay on the same indifference curve. Okay, so staying in the same indifference curve is basically telling us that you would like to achieve the same utility level. Then if you would like to achieve the same utility level, the utility that you are getting from consuming the extra cup of coffee, okay, which is 1 times the marginal utility of coffee, should be equal to the amount of the tea that you would like to give up, okay, times the marginal utility of tea, okay, that you are losing from each unit that you are giving, okay, and we are defining marginal rate of substitution as this y. Then if you do the math here, okay, then you will see that there is a direct relation between the marginal rate of substitution and the marginal utility that you are getting from the coffee and the marginal utility that you are getting from the tea. Okay, so I just realized that so we haven't defined the marginal utility. Okay, so in a clear way. Okay. So for example, so if we are looking for the utility function, okay, composed of coffee and tea, okay, and the marginal utility of coffee is the derivative of the utility function, okay, with respect to coffee. Marginal utility of t is equal to derivative of the utility function with respect to t. Okay, so I didn't show it here, but so there should be a minus sign here. Okay, and the marginal rate of substitution is the negative of the ratio of the marginal utility of another coffee to the marginal utility of another t. Okay, so which is marginal rate of substitution is negative sign. It is du over dc divided by du over dt. Okay, so this negative sign is basically to represent the slope. Okay, so remember that. So whenever we have a line like this, okay, the slope is negative. Okay, and the marginal rate of substitution is the slope of the indifference curve. Since our indifference curves are like this, okay, and the slope is equal to the tangent point, okay, so we will always have a negative sign there. Okay. So let's stop for a second here, okay, and so let me ask you if you have any questions.
No hocam.
Okay. Bir sorunuz yoksa devam edeceğiz. Hani burada let me explain in Turkish, okay? So, burada bizim için önemli olan hani şu tanıma ders bittikten sonra bir daha bak. Tamam mı? So once you look at the definition one more time, okay, you will see that so the only thing that we are representing this equation, okay? The thing that you are lose the amount of utility that you are gaining, okay, should be equal to the amount of utility that you are losing. Okay, and if you do the math here, okay, so you can represent this margin rate of substitution as a ratio of the marginal utilities. Okay, and the marginal utilities are just the derivative of the utility function with respect to what code that you are looking for. Okay, and don't forget to put this minus sign here, and this minus sign is just to represent the slope of the curve. Okay, for example, so if you were looking for this kind of the curves, okay, or the lines, the slope will be positive. Okay, so that's just a representation. So for this class, we will be focusing on three types of indifference curves. Okay, the first one is straight line indifference curves. And this is the case when two goods are perfect substitutes. Okay, which means that a consumer is completely indifferent as to which to consume. So this indifference may be in a different ratio, but basically, so the utility function that we will be using is, so let's say that we are having two goods here. Okay, so this is the amount of good one, amount of good one, and this is amount of good two. Then the utility functions that will represent those kind of the indifference curves is a times good one plus b times good two. Here a and b are constants. Of course, they are positive constants. Then the marginal rate of substitution for those kind of the indifference curve. What will be the marginal rate of substitution here? Okay, it is marginal utility with respect to good one, Q1, divided by marginal utility with respect to Q2. So let me be more clear here. Minus du over dq1 divided by du over dq2. Okay. So what will be the margin rate of substitution for this kind of the indifference curves? Let's think about it one more time. Okay, so I'm just taking the derivative of this function, okay, with respect to q1 and q2. If I take the derivative with respect to q1, it will be a, okay, and if we take the derivative with respect to q2, it will be b, okay, so it will be minus a over b. Okay, so this ratio is basically, so it can be 1, it can be 2, so whatever a and b are, okay, so you will have that ratio, okay, so it will be basically giving which one is giving you higher utility. Okay, then the second one is right angle indifference curves. Okay, so this occurs when goods are complements. So which means that consumer is interested in consuming only in fixed proportions. Okay, so which means that, for example, let's say that left shoe and right shoe. Okay, so basically you will always consume one left and one right together, okay, or two left and two right. Okay, so basically your utility will increase if you increase the amount of consumption of both goods together. Okay, so you don't want to consume, okay, so you don't want to increase one of the so you don't want to just increase your consumption for the left shoe, okay, without increasing the consumption for the right shoe. Okay, so let me draw the figure for the initial one, the straight line. So these are the straight line indifference curves. Okay, and for the right angle indifference curves is basically will be represented by the following function. Okay, the utility that you are getting from Q1 and Q2 is minimum of IQ1 and AQ1 and sorry, minimum of AQ1 or BQ2. Okay, so this is something a little bit different than what you have seen before. Okay, so this minimum function says that utility equals to the minimum of AQ1 and BQ2. Okay, so let's think about A and A is equal to B is equal to 1. Okay, so your utility function is given as minimum of Q1 and Q2. Okay, so suppose that I give you different amounts of Q1 and Q2 here. Okay, and you are interested in the utility that you are getting from those consumption. So let's say that 1, 2, 2, 2, 1, 1, 3, 2, and 2, 3. Okay, what is the utility of consuming 1 unit of good 1 and 2 unit of good 2? It is, okay, so this utility function is important. Okay, so please try to answer it, or we will go all together. Okay, so I'm asking for more responses. Sadece 3 kişi kalmadık değil mi burada? Hadi başka responslar da verelim. 1 mi, 2 mi, 3 mü, 5 mi? Nedir? Hadi 15 kişi var gözüküyor burada. It is 1. Okay, so it is 1. Okay, So we are just looking for the minimum of 1 or 2, which will be 1. Okay. What about what is the utility? Okay. What is the utility if you look at the consumption bundle 2 and 2? It is 2. Okay. So we are just selecting the minimum of them. Okay. What is the utility from 1 and 1? It is 1. Okay. So if you compare those, the first bundle and third bundle, you will see that we are getting exactly the same utility, although we are increasing the amount of the good 2 here. Okay. What about the fourth bundle, 3 and 2? It is 2. Okay. So which is basically we are getting the same utility with the second bundle. What about 2 and 3? It is 2. Okay. So let's try to draw this indifference curve. Okay. So as you can remember, okay, the name of this indifference curve is right angle indifference curve. Okay, so which will mean that so we will have something like this. Okay, this will be our indifference curve. Okay, but let's try to visualize it. Okay, so let's say this is good 1. And this is good 2. Okay, so let's consider this point. Okay, 2 and 2. So I am considering this point. Okay, so if I go on the keeping the amount of good 2 the same, okay, if I go on this direction, okay, for example, if I go to 3, okay, if I consider 3 and 2, are they indifferent? They are indifferent, okay, and if I go further, they are still indifferent, because so as I go on this direction, okay, I am increasing the amount of good 1 that I am consuming, okay, but the amount of good 2 that I am consuming is fixed, so which will be the minimum one. Okay, so in fact, so any point, okay, so on this linear line will give me the same utility. Okay, which is the utility all points giving utility of 2. What about going to this direction? If I increase the amount of put 2 by 1, keeping the amount of consumption for good 1 the same, does that cause increasing my utility? No, it doesn't cause the increase in the utility. Okay, so I'm still on the same indifference curve. Okay, so all points give utility 2. Okay, and if I so basically so this right angle is the indifference curve, okay, giving utility of 2. Okay, so I can do the same thing for 3. Okay, I can do the same thing for 4. Okay. So in fact, so there is a pivot line here. Okay, so this okay, and this pivot line is AQ is equal to AQ1 is equal to BQ2. Okay, and this pivot line is giving us these king points. Okay, so the king points, the corner points. Okay. Bu kırılma noktalarını, bu köşe noktalarını veriyor bize bu linear line. Okay. So, and the equation for the linear line is equal to the AQ1 is equal to BQ2. Okay, so if you remember that the general form of this utility function is some constant times Q1, some constant times Q2. Okay, if I know this utility function, then I can draw this pivot line. Okay, and this right angle, okay, curves are always on that line. Okay, the corner points of those curves will be always on that line. So we will come to this point. Okay, so this is important here. Okay, for example, here for this specific utility function, since a is 1 and b is 1, sorry 1, then this is just a 45-degree line. Okay, so we have indifference curve. Any question? Sorunuz yok. Süper. The third kind of the indifference curve that we will cover is the convex indifference curve. And this is basically some kind of a standard shape. And if you remember, this is the straight line. Which is perfect substitute. And this is the perfect complements. And the convex indifference curve is used to represent the in-betweens. Okay, so this will be the convex one. Okay, and the ones that we will be interested in is there will be two of them that we will be interested in. The first one is the Cobb-Douglas. Okay, so it is UQ1, UQ2 is equal to A times Q1 to alpha times Q2 to beta. Okay, so here A, alpha, and beta are constants. Okay, and the second one is quasi-linear ones. So it will have a shape of like this. Utility of Q1 plus Q2. Okay, here this is a convex function. Okay, some function of Q1. So let's say that let's forget about convexity here. It's some function of q1. It doesn't have to be linear, but the point for q2 is this function is linear on q2. Okay, q2 is some additive here. Okay, that's the main point. For example, okay, so I forgot about that. So let's turn back to this right angle indifference curves. Okay, so this minimum function. Okay, then let me ask you one point here. Okay, what is the marginal rate of substitution at this point? Okay, at point x. What is MRS at x? Nasıl bulacağız bunu? Soru anlaşıldı mı? Is the question clear? Okay, so here I'm interested in this right angle indifference curves. Okay, and let's say that so I'm looking for this x point, okay, which is the corner of this blue indifference curve, and I would like to calculate the marginal rate of substitution at this point x. Can I calculate it? Okay, so let's think about it. Okay, so forget about this indifference curve. Okay, what is MRS? It is the slope of indifference curve. Okay, so what is the slope? So we may have some different shape of the indifference curve. Here, the slope is basically the slope of line which is tangent at that point. So if we are looking for example, this indifference curve, okay? If I am interested in the slope at this point, what I am asking is basically so draw a linear line, okay, which is tangent at that point. Then the slope of this linear line, okay, slope of linear tangent line is MRS. Tamam. Burası açık mı? Burası tekrarladım ben sadece definition. So I have just repeated the definition. Okay. Now let's consider this right angle indifference curve. Okay. I am looking for the slope of that point. This is good one. This is good two. I am looking for the slope at that point. Okay. So which tells us, okay, so the definition says us to draw a tangent line, okay, at that point, which is touching this indifference curve just on that point. okay, and calculate the slope of this line. Can I do that? Hadi bakın, bu noktayı anladıktan sonra bugün bitireceğiz. Hani burası çok önemli bir nokta. So this is a very important point. Okay, so once we understand this point, okay, so I will call the day. Let me draw them better. Okay, so let me have a better drawing. Okay. The margin rate of substitution of an indifference curve is the slope of the tangent line. At point. Okay, so I'm giving a specific point is the slope of the tangent line at that point. Okay, so it's not -1 or 1. Okay, so let me explain. Okay, so let's try to see this all together. Okay, so if our indifference curve is let me say that a well-shaped indifference curve. Okay, so which has in fact a curve. Okay, and I am interested in the marginal rate of substitution at this point. Then it tells us that, okay, draw the tangent line, okay, so which is just touching that point. Okay, it is just touching at one point. If I draw some other line, okay, so it cannot touch at that point, or it may be touching in a different point. Okay, so there is a unique such tangent line. Okay, then I look at the slope. But if I have this good one, good two, okay, if I have this right angle indifference curves, okay, the question is, can I have more than one tangent line here? Okay, yes, no, let's try to do that. Okay, so I'm just looking for a linear line, okay, which is just touching at that point. Okay, so this is a tangent line, right? I can do the same thing here. Okay, I can draw something flatter, okay, which is also touching at the same point. Okay, moreover, I can do more. Okay, so this is another one. Okay, some flatter tangent line. Okay, so since this is a kink, okay, burada köşe olduğundan dolayı, since this is a corner, I can draw many tangent lines here. Okay, then the question is, this orange one, this red one, and this blue one have different slopes. So which means that they are corresponding to different marginal rate of substitution, which say that which one is the marginal rate of substitution. So whenever you are not sure about which one is the right marginal rate of substitution, then the answer is corner points do not have MRs. Okay, they do not have slope, no slope. Their slope is not defined. Okay, so whenever I ask the margin rate of substitution for this right angle indifference curves, okay, the answer is there is no slope. There is no such a thing for margin rate of substitution for those kind of the indifference curves. Clear? Bu köşe olduğundan dolayı hani köşenin slope'u tanımlı değildir. Normal bir şey aldığınızda. Hani unutun indifference curve olduğunu. Normal bir figür, bir grafik olarak aldığınızda, köşe olarak aldığınızda birden fazla tangent line çizebiliyorsanız, then it means that the derivative is not defined at that point. Okay, so which means that in other words, there is no slope. If you have a cone, okay, so then you can draw many different tangent lines. And it means that there is no margin rate of substitution here. It's not defined. Okay. So this is all for right angle indifference curves. Sorusu olan var mı? Yok. Güzel. Then let's turn back to here. Okay. So if I have Cobb-Douglas utility functions, okay, what is the marginal rate of substitution? So the marginal rate of substitution is minus marginal utility of cut1 divided by marginal utility of cut2. Okay. So if I take this function, and if I would like to take, so the marginal utility of cut1, so let me be more clear here, du over dq1, so there is minus sign, and du over dq2. Then if I take the derivative of this function with respect to q1, okay, a will be constant. So I'm working on the numerator. A will be constant. Then I will take alpha in front. Q1 alpha minus 1 times Q2 beta the same. Okay. And if I work on the numerator, okay, it will be A will be constant here. Now B Q1 to alpha times Q2 to beta minus 1. If I do the math here, I will get Q2 over Q1. Of course, alpha and beta. Okay, so the marginal rate of substitution for Cobb-Douglas utility function, so which has this shape, okay, is minus alpha times Q2 divided by beta times Q1. Okay, so what about these quasi-linear utility functions? Okay, it will be minus, I don't know the exact formula for uq1, okay, but let's say that we are just taking the derivative of uq1 with respect to q1. And what is the derivative with respect to q2 here? It is 1. Okay, so which means that it is du du q1 dq with minus. Okay. Sorunuz var mı? Any question? No? So I will just define one more thing and I will call the day. So far we said that, so we are just working on the the taste. Okay, we are just working on your preferences. Okay, and we are not taking the price of good, okay, your income into account. Okay, and we just work on the shape of the indifference curve right now. So I will just define the the constraint version of this problem. Okay, so for the consumer choice, okay, so basically the point is I'm giving you some options and you are selecting one of them. If you are not limited, okay, you will select the best one. Okay, but sometimes you may be limited because of the price of the goods, because of your income. Okay, then you may not be able to select any of the bundles that you would like to get. Okay, you may be just able to select the bundles, okay, so within in your budget set. Okay, and we will define for that purpose, okay, we will define the budget constraint. Okay, so which is always known, also known as budget line. So budget line is the bundles of goods that can be bought if the entire budget is spent on those goods at given prices. Okay, now we are considering the prices of the goods. Okay, and we are also considering something called budgets. Okay, so this will be the income. Okay, and this will be the price of good one and price of good two. Okay, so actually, so if you would like to represent the budget line, okay, in terms of a function, okay, what it is telling us is okay, so let's say that you are considering P1 as the price of good one and P2 as the price of the good two. Okay, so the maximum amount of good one that you can consume with this price will be represented by Q1, and the maximum amount of the good that you can consume is Q2, and you will have an income. Okay, so this is budget equation. Okay, and if you would like to draw it, so this is good one, this is good two. Okay, so this will be a linear line. Okay, and basically we can draw this linear line by finding the maximum amount of good one that you can consume. So what is the maximum amount of good one that you can consume with this budget? It is y over p1, and the maximum amount of good 2 that you can consume is y over p2. Okay, so I just point those maximum amounts here. It's y over p1, this is y over p2, and I'm just connecting those 2 points. Okay, so this is h2. Okay, so this is the maximum amount. Okay, but you can consume also this region. Okay, so this region is also achievable for you. Okay, and this region is called the opportunity set. Okay. So let's stop here. Okay. Any questions?
No hocam.
Gayet güzel. Şimdi burada durduk. Çarşambaya dersimiz yok. So let me stop the recording here. I don't know, so I can stop it later. Okay, so we don't have any class on Wednesday due to the national holiday. So we will continue on Friday. I will give you an assignment today or tomorrow. Okay, so which is covering the parts that we have done so far. Okay, and on that assignment, okay, I will add a few questions. Okay, for the parts that we will be covering on Friday. Okay, so just a few questions, and it will be due mid next week. Okay, then I will give you some on Friday or after that. So I will give you some study questions for the midterm one. Okay, so you will be responsible for the chapter 2, 3, and 4. Okay, so we haven't finished chapter 4 yet, but so just the last part of the chapter 4 is left. Okay, so for the midterm, so you will be responsible for those 3 chapters. And can you download the lecture notes? Okay, so that I have uploaded to the Maisu. Okay, chapter 2 and 3. Can you download them? Good. And so again, so if you have any questions, so do not hesitate to ask me. Okay, then otherwise I will see you on Friday. Okay, bye bye.
Thank you hocam. Bye bye.